Hello, everyone.
Hello.
All right. Hello. Okay, so let's get started. So this is ITS 372, 2 p.m. All right, so just a few reminders before we get going with the class today. As you know, this is basically the final week of new material. As you know, next week is presentation. So next Monday, so I want to remind everyone, next Monday at this time between 2 and 4, we're all going to meet in this medium, Zoom, just like we do today, but next Monday you guys will do your presentations, okay? So you have two projects, Project A and Project B. We will have both Monday and Wednesday between 2 and 4 to do the Zoom presentations, okay? So please, everyone, be ready for that. Make sure you present. I believe all you'll have to do really is share your screens, just like I do, right? And then you can all talk. Everyone in the group should present. Remember, you're going to do your demo of the Hadoop lab, and also you're going to do your presentation of the topic. There's no fixed schedule or anything like that. Basically we're going to do this on a first come, first serve basis, but make sure you do present. Okay, we have all of next week for that. And then the week after that is finals week. Okay, finals week. Well, when, we will have our final exam, which will be similar online type of a test. Okay, and so that just leaves this week, today and Wednesday to finish up the topic. So today, I'm going to go over security, right? So, I'm going to do a lecture on sysadmin security, and then you have basically a lab assignment, which is this one, host firewalls, and then we're going to cover, pretty much wrap up the semester that way. Okay, so that, remember, this will be the conclusion of your semester-long course on basically the Unix operating system and system administration topics in general. Okay, remember, the final exam will be comprehensive. So that means it'll include everything from the beginning of the semester until what we cover this week. Okay, so that's the plan. Hopefully all that makes sense. Are there any questions before I get started with today's our last lecture, basically?
Professor, is the final exam on the following Monday then, or Wednesday?
We're gonna follow it the same schedule that has been given to us, given that schedule sometimes changes from the regular course schedule, and students could have a conflict where, if I change the time of the exam, it might conflict with something else. So I'm just gonna follow basically whatever is given for us. So if you want to know the final exam time, it's gonna be, you have to go to Google, right, and then just do PNW final exam schedule. And then, so this is going to be for final exam schedule. We are in exam time spring 2020, right? If you flip that page, and so now we have to look for the class. So our class is Monday and Wednesday at 2 p.m. So we have to look for that. All right, so according to this, Monday and Wednesday classes, 2 p.m. The exam is on Monday from 2:45 to 4:45. Susanna, did you get that?
Yes, I was writing it down. Thank you. Yes.
Yeah, okay, so, but you can always just look it up. That's usually what, so that's gonna be so our final exam will be, what is it, in 2 weeks? It'll be Monday from 2:45 to 4:45. So I'm gonna have to set that on the on Blackboard to open and close at those exact times.
Okay.
All right. Any other questions?
That's it.
That's it. All right, great. seems like there's no other questions. So then let's get started with today's topic. So I know you guys really enjoy things related to security. And, you know, this is the last topic in Unix, as, you know, it may not, you know, it shouldn't be a surprise that Unix is central to a lot of security things. You know, one of the reasons why you take this course, 372, is because a lot of the labs on a lot of the topics that you will do in other classes use Unix, sorry. So they use a lot, we use a lot of Unix. And so, you know, this is, that's why this is important. So today, you know, I'll talk about some security topics in general as they relate to system administration, but usually when you talk about security in Unix, you want to talk about firewalls, right? So firewalls is really, you know, one of the central things. Now, bear in mind, we've talked about security a lot this semester already because, you know, Unix is built around files, and, you know, the mechanism that governs files is access control, right? So the read, write, all those permissions and user accounts and everything. So you already spent a lot of time on access control this semester. And so now, you know, that is also security. And now we're just going to focus on the firewall. So actually, the way that I like to do firewalls in my courses is kind of very gradual. So in 372, I do the UFW firewall, okay, which is what you're looking at. So I encourage you to do this lab. This will be your last lab. I'm going to leave it open until the last day of class. It should be a fun lab, actually, and it's a lot easier, I think, than anything else we've done so far. Should be pretty straightforward. But what I like to do in 372 is we go over UFW, and UFW is basically, it's like the easy, it's literally called the easy firewall. So it's the easy version of the Unix firewall. So actually the Unix firewall is called IP tables. That's really the main engine that's in the background. But IP tables is a little bit more difficult to grasp initially. And so UFW is like an interface to IP tables. So that's really what it is. It's a way that you can more easily write the rules that can then be sent to IP tables. So the way I like to do it is, you know, in 372, we look at UFW, which is this lab. In 350, we look at IP tables, right? So we go in, you know, into more depth. And once you understand IP tables, you make a Linux operating system into a router, which is something that, you know, we can do, right? So in this semester, we've only treated our Unix as a host, but, you know, in 350 and in other courses, you know, we will make Unix a router, right, by having two interfaces, two network interfaces. In the past, we've done that with Raspberry Pis. Given the situation right now, you know, we would need that physical hardware, but we'll see how that goes next semester. You know, with all this crazy stuff going on, but it can be done with a VM as well. So for those of you that like to, you know, try things out, it's actually easily done as well. So anyways, so that's the way that I approach this. So we cover, you know, UFW in 372, just a quick introduction. Then we cover IP tables in 350. And then we cover, you know, Cisco type of appliances for firewall use in 454, right? And so it's, you know, you see it 3 times is basically my point, you know, and the idea is that that should, you know, it's better, right? It's more reinforced. It's also every time it's a little bit different. Same principles, and that's hopefully what you're getting out of it, but, you know, syntax changes, etc. All right. So, so as I said, so we have this simple lab, and this is one of my, you know, pretty much the generic lab I usually write with all the numbers. And so you just have to follow this sequence, right? So by this point, you know, you should feel comfortable with the Unix operating system. You've had a semester on it, right? So you can install, so basically in this lab, and, you know, I'm starting with the lab, and then after that, I'm going to go back, you know, go to the slides. I just cover some generic topics, more related to sysadmin. So as you know, there's more of the managerial sysadmin versus, you know, the more technical. So in this particular lab, you know, you'll install UFW, you can see that there. Are you guys seeing my Word document?
Yep.
Yes.
All right, great. Yeah, so that should be, that's the lab. As I said, this is your last lab. So you'll install the firewall there. So let me get the pen going. There you go. So you'll install the UFW. So UFW, that's the name of the firewall. Usually once it's installed, you can just enable it and disable it. One of the questions that I always say, whenever you take classes with me and you're having problems, you're trying to ping a machine or you're trying to SSH into it and things are not working. One of the common things I say is, did you disable the firewall? Remember that a firewall is a mechanism that does not allow things from the outside going in, right? So if this is your internal network, or basically the machine is an internal network, either one, it basically blocks, right? So it blocks, and anything that initiated, obviously if something initiates from the inside and then it's just returning, that will be allowed in. There's a little table in there that keeps track of that. But if it's something that initiated, like a hacker or something initiated from the outside, it's just going to bounce, right? It's not going to be allowed in, because that's what a firewall does. It's like a shield. It doesn't let things through because all the ports basically are closed. All right. So, that's what you will do. You will enable or disable it. All right. Then as you can see here, I'm then asking you to use SSH, right? So this lab, we've already talked about remote services and SSH, and basically I'm just going to ask you to use SSH to try to connect into the device, and then you're going to add rules in here that prevent that type of access. So initially, these rules are the easiest to understand. Once we get into more depth of firewalls and other courses, you'll see that actually the rules require a little bit more, there's a little bit more difficulty to them to understand, but at this point, they should be pretty straightforward. So as you can see, one example is sudo UFW allow 22, right? So what is 22? What is port 22? Anyone? What is TCP port 22?
SSH.
SSH, exactly. And so that's really how it works, right? Basically firewalls just look at packets, they scan them, and then if the packet is contains a value that it cares about, it takes an action, okay? And so that's what you're gonna do in this lab. You're gonna add the rules and then try them out. So usually what I recommend is in your screenshots is first run the whatever scenario without the rule, and then it should work, right? And then you prove that, you have a screenshot of it working. Then you say something like, now I added this rule, here it is. And then now you run it again, and if it's a firewall rule, it probably means that something will not be allowed through, okay? Will not be allowed through. All right, and so after that, you can follow all the directions here. As you can see, it's gonna show you how to deny things. It's gonna show you the rules in the firewall, right? And so you can do, you can try all the configurations, deleting, enabling, disabling, etc. Right? So follow all these steps. Okay. You're also going to look at how to prevent pinging. So pinging is a very common thing that firewalls, always address, right? So by default, some firewalls don't actually allow ping to go through. And so here, this is going to show you how you can actually go, you remember, to etc UFW, right? That's usually where you have the settings of a program in Unix. You're going to go in there and you're going to basically find a file where you have some rules. All right, and if you notice here, what this is doing is it's dealing with Icmp packets. So Icmp packets are basically ping packets, okay? So these are the ping packets. So notice here that a lot will happen with the type of packet. So for instance, it's gonna address echo requests, you know, and so on. And then here is the action. So usually when you're writing firewall rules, you do things like the word accept or the word drop or something along those lines to indicate the action that the firewall needs to take, okay? So you're also gonna play with that mechanism of Icmp. And again, with that, you would basically do, okay, first I'm gonna ping and it's gonna work, then I add the rule, then now it's not gonna work. So that should be the process. Okay, and then you have some problems here to figure out how to block an IP. So again here, you know, whenever you get a packet, you can look at the TCP header or UDP or Icmp and figure out parameters in that packet. You can also look at the IP header and look at things like the source port, the destination port. So in this case here, you're going to learn how to block packets based on, you know, some kind of an IP address. All right, and then we're going to go back to our little examples with Netcat, right? So you can try that as well. You can play around with, if you remember, we saw that in file system analysis, a very good tool for creating tunnels, right? So for tunneling through data, you know, you used it in the file system analysis to move the image from one machine to another across the network. So here you're going to once again use this, you're going to use this tool to, you know, do something with the security, okay? And play around with the firewall. So you're going to solve all these problems, and then at the end, you're going to, you know, finally report your results. Now, I have on here something about scripts, right? A Python script that can add 2 rules to the UFW firewall to block. So you should be able to do this, right? This is something that, you know, you should be able to do because you already know that anything that you would type on the command line, right, you can also run from Python or Bash. And so I leave it to you. Now I wrote Python here, and you know, that's really, you saw process, but, or you could use do a Bash script, whatever you want, but you should at this point be able to, at this point, you should be able to solve that script, okay? All right, and then that's it then. Don't forget, once you're done, remove all the rules from the firewall, because if you leave them there, you know, and you use that VM later in the semester or later, you know, in another course, you know, you may end up, you know, things won't work and you'll forget that, oh, I disabled ping, you know, so everything. So in this lab, it's very important that any rule that you add, you know, anything that you change, that you set it back to the way it was. Okay, so make a note of that so that you don't end up with rules in there that are very easy to forget. All right, so that's, as you can see, the lab is short, very simple, but it should give you enough to see the functionality of the UFW firewall. As I said, this is the simplest, it's the UFW host-based firewall. It's the simplest implementation of a firewall for the Unix operating system. Okay, so are there any questions related to this lab? Okay, it seems like there's no questions. So this is going to be, as I said, it's due, you know, the last day of classes, not the last day of finals. Remember, and I should remind you, all materials, you know, that includes everything, you know, your reports, your lab reports, your project reports, everything needs to be submitted to me by the day of the final. That's your last day to submit things, because at that point, I have to grade everything, and, you know, and if you know, I may grade and submit things before you, you know, so as long as you've submitted everything by the day of the final, right, I should, everything that's due in these next few weeks, I should be able to, it'll get included in your grade. But if you were to submit late, I may have submitted your grade to the school before you send it to me. All right. So let's.
What?
Yeah, go ahead.
What day is that again specifically?
The day of the final, the one
Yes.
that we talked about the final exam with Susanna. It's Monday, 2:45 to. What was it? Do you guys remember? 4:45, 2:45 to 4:45.
And that's May 4th.
That is the Monday. I think so. I have to check in the calendar again. Hold on. So that would be May 4th, Monday, because that's the time slot that we have for our final exam.
Thank you.
Yeah, our final exam takes place on that day. So basically before that, obviously, because you'll be taking your exam at that time. So make sure you submit everything before that, okay? Everything. All right. So that's, we're finishing up the semester, so usually we're just wrapping things up at this point. Okay, so that was the lab. Please work on this. Should be an easy lab to do, okay? As you can see, just one simple script and then just solving these problems. And just follow the examples, basically. If you follow the examples, everything should work. All right, if there are no more questions on this lab assignment, then I'm just gonna move on to the slides to kind of wrap up the topic of security and system administration. So I need to share. All right, can you see my slides right now? Okay.
Yeah.
My slides on
Yes.
we see them.
Yes.
system administration and security. Okay. So this is more now, I gave you the technical side of this topic, right? Obviously, there's a lot of topics. Access control is one of them. You saw that things with DNS that we did in the semester, the forensics aspect a little bit of the forensics that we did in system administration, that was security in a way. I mean, pretty much anything in Unix. Cron could be security. I mean, everything could be related to security, obviously. So there's a lot of topics out there. And that's why we have, a lot of courses, like cryptography is a huge part of this, OpenSSL, for instance, right? OpenSSL is the standard for cryptography in Unix. We have that installed in the CVM, and for those of you that have taken 350, you've already seen it. For those of you that haven't taken 350, that's next semester. That's like 9-10 weeks of just cryptography. So there's a lot of things related to security and Unix. Okay, but this lecture will be a little bit broader than that. It'll be the managerial aspects of system administration. So kind of an overview of it. Okay, so I think this summarizes how you have to feel every day as a system administrator, right? So you have to be very paranoid about your system. So we have to follow a cue from Bart, the sysadmin. Right, so the idea is that you have to kind of have, there's a lot of issues that you may have to deal with, right? There's a lot of issues, and so you have to have a plan, and usually that plan begins with a risk and control matrix, or a risk assessment. So, and that's just the idea that you identify what are the assets, what are the threats, and then what are the controls? All right. So so you could do this, you could do that for sure, and be like Bart, or you can try to follow, a procedure, right? And this procedure, if you start with this, from an IT point of view, it's gonna take you to, a more secure system. you will never be able to achieve 100% security. You will just have, accepted risks, basically. But that's why you start here. So the very first thing that you have to identify, and I always talk about this. So I talk about this in 350, I talk about this in 372, I talk about this in 454. Because even though it's not a technical tool, it is certainly a tool in your toolbox. At the, after you do the RCM, the risk and control matrix, or the risk and control assessment, you end up basically with documents and policies. So you don't really end up with like, oh, here's the firewall. That will come later, but the output of this, the very first part, is the documents and the policies. And that just means, the overall, as a system administrator, I need to have, a usage policy for a lot of things. Are we going to use a firewall? What do we use it for? Do we use cryptography? Do we use user accounts? All of that. Right? And the process begins with, this. The assets, the threats, and the controls. So the assets are the things of value that you're trying to protect in your organization. Okay? And then the threats are obviously the things that could happen. So a hacker could attack your systems. Malware could, damage your files, or ransomware. Somebody could steal a server or a machine. Somebody could steal your credit card information, or disclose things, etc. Right? So those are the assets. The assets are the things you're trying to protect. Notice that these assets can be tangible or intangible. Okay, so for instance, company reputation, like what happened with Zoom, right? So Zoom, for instance, had an issue right now, even though they didn't really have that. I think they stole some passwords and they may have had some leaks. This is, it's a medium that is kind of public anyway, so it's not such a big deal, but they had some issues with, their security. And so people thought that Zoom was less trusted. So I know, for instance, that because of that, some schools in New York, I think, stopped using Zoom, given that. And so obviously for Zoom, that's not a good thing, because some of those were paying customers. And so that affected their bottom line. Although right now they have such demand that I hardly think it matters. But still, a business, a company is in the business of maximizing their shareholder wealth, which basically means that they didn't meet that objective by losing New York. And so, you wanna address, identify all your assets, and then identify what the threats are, and then you identify the controls. And the controls are the things that you will put in place. Once you've identified all that, and you've written your policies and documents, then you start looking at the controls that you're gonna put in place. And those are things like, technical things. They can be firewalls, intrusion detection systems, access control, passwords, all of that. Or it could be, managerial things. So for instance, train your workers. Train them, teach them not to use, the word password for their password, right? So enforce rules for passwords, and so on, right? So education could be one of them. Deterrence, like writing, if you steal servers from this data center, we will call the police. Or things like, somebody is responsible for making sure that the servers are updated. You don't just put it in the policy, oh yeah, we will update the servers regularly. You actually have a person, right, a human being, who is responsible for that. And so on, right? So that's really where the process of security begins. Once you've identified this, you have assets, threats, controls, you have documents and policies, then you can begin the process of coming up with the technical solutions to secure your environment. And then hopefully then you don't have to feel like Bart Simpson here all the time. All right, so that's basically the approach that we want to take here. All right, there are other things to worry about. So I'm only going to briefly mention this because I know you guys have a course on this, 352, right? Disaster recovery. So, remember, this is an overview of all the issues for a sysadmin. So definitely, I should mention that you have to worry about disaster recovery. In particular, this applies to a system administrator, right? Because a system administrator will need to implement some things, right? So you want to identify key services that cannot go down, right? So the Blackboard, for instance, the email server, those are essential things to the operation, VPN, you know, and so they need to identify those. You need to find ways to establish quick restoration, maybe by having duplication of sites and so on. So you need to plan for this from the point of view of disaster recovery, first of all. So for instance, you might argue in our current situation that the disaster recovery plans for some companies may not have included pandemics, right? So now, you know, certainly going forward, companies will have to look at pandemics even, okay? What happens if another pandemic comes, you know, or, you know, how do you update these plans, these policies to account for that, and then identifying the services that are essential that need to be updated, okay? So anyway, so one of the areas is disaster recovery, and that includes, you know, lots of things, fire and earthquakes, having some insurance, lightning and tornadoes. So we saw some damage with tornadoes recently, right? So those are issues that are important. Hurricanes, not in this area, but, you know, in other areas like Louisiana, you know, and so on. All right, so those are important. So as I said, the important issues to define is, you know, what would be a loss, right? So loss of service, for instance. You know, how does it affect productivity and revenue? Those are the key questions that you can ask to identify, you know, critical services in disaster recovery. Also losing data, right? So if Blackboard went down and all your grades were lost, that would be terrible, right? So those have to be very important things that need to be accounted for, and then there has to be backups, etc., to avoid disaster. Right? There's also issues with legal obligations. And so you want to have disaster recovery plan. So, you know, usually one solution is, you know, backups, right, and a backup site for running operations as well. Okay. So as you can see here, one of the recommendations is backup everything, and that's why we looked at that a little bit this semester by looking at, you know, cron jobs and looking at basically scripts that could run backups for you regularly. All right, and so and at the end of the day, as I said, you know, when I go back to the previous slide, you know, once you do your RCM, before you get into all the technical details, you focus on policies and documentation. Right? So that's really where everything begins as far as starting to secure a site. Okay. All right, so the next topic then is we're going to look at the security policy. So the security policy is itself, remember, not necessarily, I'm not talking about something specific to Unix, but certainly something specific to system administration. So this is an important thing to have in system administration related to security, and it's called the security policy. So as you can see here, you know, that's, you know, system administrator, right, writing the security policy there. All right, so let's go ahead. So this is this is all tied in, as I indicated in the first slide. Everything begins or starts with risk management. Okay, so risk. So, you know, and that just says that you can't really secure your site to 100%. I mean, because that would probably be too expensive, right? You know, imagine we're gonna have a double backups or triple backup sites. You know, the most expensive hardware, etc. It just, you know, it may not be feasible for an organization. Remember that an organization doesn't exist to secure the site; it exists to make money. And so, security is always in a constant battle with resources, right? With, you know, economics of the organization. So in essence, you end up with this idea of risk management, okay? You need to manage it. So risk is the relationship between your assets, the vulnerability characteristic to those assets, and the attackers who wish to access or modify those assets. So you want to identify or quantify that in some way. What is the probability that an attacker will exploit a vulnerability to one of my assets? And that's the definition of risk. Right? And so then here you have your assets, as we talked about, a lot of different types of assets. Then you identify the security goals or the principles. So in any environment, what do you want to achieve? Confidentiality, integrity, right? So confidentiality is that nobody can read your data. Integrity is that no one can alter your data or modify it, right? And then you have, network availability, that the system doesn't go down, right? So, the classic example of this is the denial, DDoS, right? So denial of service attack, distributed denial of service attack, right? So, and also there's authentication and various other things. Okay, so these are the security goals. You want to achieve this. You want to maintain your data confidential. You want to maintain integrity so that nobody changes it. You want people to only authenticated people to access your data. Okay. Excuse me. The threats are, related to financial motives or just people creating disruption, and so there's a lot of things there, hackers, phishing, all kinds of things. The vulnerabilities, you already know this. One of the important ones for Unix is updates. Right, so if the data is not updated, you're going to have an issue, right? So you want to patch it, do patches and make sure that the data is updated. But there are other vulnerabilities like bad passwords, unused services with open ports. So that's, you want to close those ports, unpatched software. Those are common things that every system administrator needs to worry about. It's not even, it's not even like the complicated things that you need to worry about, right? You simply need to worry about these basic things like the passwords, the user account management, which, these are things that we saw in Unix, turning off services, we saw that, and then patching our software or running updates. All right, and then other things like, you don't want to transmit data into clear text. So for this, you want to use cryptography. So you want to use crypto, right? And so on. Physical access, uneducated users, etc. So there are many types of vulnerabilities. This is just an example of some basic ones. All right, and given that, then you have the defense types, which is basically your controls. That's usually the term that is going to be used in finance. It's a term from finance and accounting that has been around for a long time, and then now obviously information systems, hold data, and so the controls are still the things that protect them. So some, one of the basic concepts that we can use is something that you may have heard before. It's called defense in depth, right? So the term defensive in depth just basically means that security is a system. So security is a system. And so defense in depth means that you provide security by providing many pieces of a system that do different jobs and they all work together. So it's, if one of those is weak, it might weaken the entire system. So that means you have firewalls like the topic of today, that provides the network perimeter, right? The control at routers and different devices. You have other concepts like intrusion detection, which we will cover in 454. And then you have a host firewall. And system hardening, which system hardening is, the recommendation that was given before. System hardening relates basically to this. To harden the system, you take unused services and close them, right? And you patch your software. So that's the idea of hardening the system. It just makes it more secure by turning off services, closing ports, patching the software, etc. Okay, so as you see, you know, as I indicated in the very first slide, we have once again arrived, you know, gone through the process of looking at assets, right? So we look at assets there, then we looked at threats. Oops. Threats, and we look at controls. And controls, you know, usually like the next term we want to look at within controls is defense in depth. So this process, I like to stress quite a bit. We used to actually have a course on this. So we would spend one whole semester course on just RCMs. We don't have that course anymore, you know, given that we can't have more than 120, but it's certainly something important, right? Because it is, if you go, so that's, you know, that's usually why I start with this slide. First of all, but also I start with this slide because you don't really, you know, if you think of security without structure and how you're doing it, you're going to end up like that, right? So you want to have a process that you follow, and then that process allows you to, you know, go deeper, basically. You go deeper into the issues. Okay, and so this is a process that starts everything, all right? And once you've identified this, you really have like a little binder or an Excel spreadsheet that now lists all my assets, all my threats, all my controls, my defenses that I'm going to have in place, right? You can see them here, and there's a lot of them, right? That, you know, authentication, you know, software and secure configuration, patches, firewalls, IDS, malware, and those are the technical things, right? And this like kind of summarizes what I just said. Risk and control matrix, it's really an Excel spreadsheet. That one column is assets, one column, then it has the matching columns for risks and controls in place. Now, once you've completed the RCM, I would argue that the process should look something like this. So first you do the RCM, which I already described. Then you start, you know, this gives you some documents. But you still maybe haven't looked at the technical issues. Just because we said have a malware or have cryptography or have patches, that doesn't mean that we've arrived at a specific technical Unix solution, right? Or Cisco solution or Windows solution. We just have that information, right? And so we want to get to that, and that's that would be somewhere around here. You know, the actual technical and non-technical controls, where you start to really dig, you know, go into, oh, I'm going to use RSA cryptography, I'm going to use this, you know, ASA firewall, or, you know, some more advanced device. But before we get to that, there's a step in between that doesn't always get as much attention, but that it is equally important. And that is this, as you can see over here, that's the security policies. The security policies. All right, and the security policies just really talk about their documents. Again, these are still non-technical. All right, they still don't need to be technical, right? They just, you know, you're still just providing like a set of rules or instructions on how to think. So here, you know, imagine with this COVID-19, right? So write a policy for that. Well, it's social distancing. So now the classrooms, I heard that some schools have opened, for instance, but the students can't sit next to each other. They're like spaced out a little bit more, right? So that might be the policy that still needs to be written, right? So that needs to be written, and it's going to have those instructions. Or, you know, they're just, you know, information on how to proceed, really. And so it's, as it relates to the IT practice, there's security policies for a lot of things, right? So there's security, you know, for instance, there's security policies for users, right? You know, let's say, there's something like acceptable use policy. There's the monitoring and privacy policy. There's remote access policy, right? So the remote access policy might say, you know, what services, you know, we provide. So secure connection to the university. That's going to be like a VPN. And that's as far as it goes. It might state who gets access to the VPN, right? So it might be that, you know, not all students get access by default. They need to request it through some process. You know, the monitoring and privacy policy, pretty much anything we do online, any service, you guys go to Facebook, YouTube, whatever, and you probably, before, whenever you were signing in, you were shown a privacy policy, which you don't read because it's, you know, 1,000 pages or whatever, but really it just needs to say a sentence, right? Anyone know what that sentence most likely says? You have no privacy in our medium. That's really honestly what it says currently. And so, that's because there's actually no legislation. So there used to be a little bit of legislation. I think there's some legislation in California, but nationwide there is no legislation. And, you know, hopefully there will be in the future some legislation that, you know, forces companies to, you know, respect your privacy. But, you know, that's really what this is it's kind of a document that talks about an issue, not necessarily in technical terms, but it is really important. It is very important because it's a lot of the time it's motivated by legal things. Okay, and so for instance, you know, healthcare, you know, might be governed by things like HIPAA, and so their policies, again related to privacy and things like that, are seriously. So healthcare is an area where it's completely different from what social media is doing. You know, in healthcare, you have laws, you know, regulations, HIPAA, and that governs the policy that has to be written in IT departments for, you know, healthcare. But that's completely different from the policy that you have related to privacy in social media sites, and that's simply because there's no law. You know, there's no law really supporting that. So that's the idea. Okay. All right. And so anyway, so hopefully that makes sense. So the policy, again, is just a document that you write, still non-technical, but it's very important, and it can talk about anything, right? If it's somewhat related to the information systems of the company, the IT practice, you know, there should probably be a policy for it. Okay, you know, other ones, just log retention, network connectivity, you know, all kinds of things can be written into policies. And so as you can see, if you guys work, you know, maybe as consultants, you know, you work for KPMG and you go to secure a site, you know, some mining company in Wyoming or wherever. And so what are you going to do? If you're starting from scratch, or if you're just auditing to kind of get a big picture, well, you have to start here, right? At the RCM, kind of follow that process, make sure it makes sense, then look at the security policies, tie them back to the RCMs, right? The security policy should say that some people are responsible for things. That's one of the key things, right? So, people are, you know, responsible. So security policies, and then, and only then, do you start getting into the technical and non-technical things. And then after that, you get to specific areas like the UNIX system, the network, you know, Windows systems, and so on. All right, I usually at this point like to stress that, you know, I know you guys, you know, you probably like certifications, and you're going to be doing a lot of certifications after you graduate in cloud and CompTIA and the security ones that are out there, and those are all great. However, I like to point out that there's a certification that is well respected for this area. All right, there's, you know, so there's one, and it's a good one to have. I think, you know, you need like 5 years of experience if you're in the field, like an IT person. But it's only one exam, I believe, that you have to take, and the exam includes technical and non-technical things. And the certification is called the CISA. Oops. The CISA. All right. And so the CISA is a Certified Information System Auditor. So you know, for those of you that really like certifications and things like that, that's one. It's a not very technical one, so it's not going to be like a UNIX specialist or security ethical hacking kind of a. But it's certainly one that covers some of the technical, but it also covers some of this. And so, you know, and you can work just in this area as well. That's what I'm trying to stress, that even though it's more managerial, it's equally important. Okay, it's very important to take a look at this, because companies need to have this in place because of laws like HIPAA, Sarbanes-Oxley, FERPA, and many others. So Sarbanes-Oxley, it's for financial institutions, and so banks, you know, Facebook itself, any publicly traded company that, you know, that has presence in the stock market needs to provide financial statements that are signed off by the executives of the company. And so this kind of work is really, really important. All right. Are there any questions so far, guys? Comments? Okay, no questions. You guys can see my slides still, right?
Yes.
Yeah.
Okay, great. All right, so let's keep going. So once you've completed that, you know, the whole process, going through all these steps, and then you arrive at, you know, the policies. There's going to be lots of policies, right? You know, there's going to be, and then you start to get into procedures that you're going to implement on how to do things like OS hardening, and, you know, so OS hardening, you know, secure the physical system and all of that. So it starts then getting into the details of the organization. Okay? And you can see some examples here of all of that. Okay, so these are now things that you're going to specify, like procedures of what is, you know, let me go back. So what is OS hardening? You know, what should we do? And what is securing the physical system, right? You know, place servers in a physical secure location, check logs, so review logs regularly, right? Automate that process if you can with syslog and scripting, okay? Security auditing, so auditing just basically means tracing something, looking back at information. This can be both internal and external. And internal just means that within your organization, your system administrators do the job, or it could be external, where you bring in a consulting firm and they look, like, you know, when people say pen testing, and the pen testing is only one, you know, it could be at multiple levels. I mean, this usually just falls under business consulting. So, you know, you do that. So audit areas can include compliance with security policy. So the idea is that you wrote the security policy, but are you following it? And that's why you need to have sign-offs, all right? So that's one of the very, very, very important things when you write a security policy or put controls in place. Someone is responsible. For that control. So that's the example of, you have a policy. I'll give you this great example. You have a policy of update the systems regularly. And then you have a breach, and you bring in some outside consultants. They look at the breach and they determine, well, it happened because Apache 2.0 was being used, and they should have been using Apache 2.3, but they didn't update the software. You guys see that? And so that's a problem. And then they say, but it's in the policy. Yes, but who was responsible for that? And then you look at the system administrator, and that person looks at the manager, and the manager points to the CFO, and then it just creates this cycle where nobody takes responsibility for it. And so that's why someone is responsible for that control, and you have that in writing. You have that in writing, right? So that's really important. So like I said, all of these things are really important because it may seem trivial right now, but when somebody sues you, right, or sues the company, you get a lawsuit to the company, you go in front of the judge and nobody was responsible. The policy was in place, but no one was responsible for executing it. It was maybe an implied thing, but no one really did it, okay? And then other things, you want to check physical security of the data center, up-to-date patches, scan the network, and pen testing. Okay, so these are all the areas that could be part of a audit. And then other things, other recommendations, disabling remote access, obviously sudo, we spent a lot of time learning about sudo this semester. Firewalls, right? This is what you're doing in your lab, okay, and so on. All right, so that concludes security policies, that discussion. Are there any questions? All right, so it seems there's no questions, so I'm going to move on to the next topic. All right, so like I said, firewalls are a big part of security, both in companies and for Unix, right? This falls under access control, right? And access control, I think we defined it at some point. It's just, controlling who gets to do what in your systems, right? So it's really about controlling the information, the content, that the data is not moved without authorization, and that you follow the principles, right, of confidentiality and integrity, authentication, availability. So firewalls are really, what are they? They are nothing more than packet sniffers, okay? They usually, whenever you think about firewalls, you're thinking about, like network things. They can be both host firewalls or they can be network firewalls. So the idea here is that this is your internal network. So you have a machine here, maybe 1604, right? And 1604 has its own UFW firewall, which is the IP tables firewall. But then you can have other types of firewalls, right? This one is a firewall that has 2 network cards, if you notice. So it's a type of a router, okay? So a router with some basic ACLs is a firewall. You see that actually here. So this is a router. And usually it has 2 network cards. It will allow traffic to go through. But if you start, you can add ACLs and routers, right? So you can start adding those in there. And so those rules will really, make it into a type of a router. And then as you start going from an untrusted network to a more trusted network, you end up, with, a firewall might be then something that just specifically works as a firewall. So the difference is that now all traffic that originates from the outside will not be allowed in. Only traffic that originates from inside and then will be allowed. But by default, traffic that originates on the outside is not allowed in. So that's really what a firewall is. So really at the end of the day, this one, has, let's just say this one has some ports open, whereas this one has, from the point of view of from the outside in, all ports closed. all ports closed. Okay, so that's really the idea here. All right. So firewalls, the need for firewalls. So as we know, internet connectivity is essential. However, it creates a threat, right? So we need effective means of protecting our networks. And so that's really why we have this idea of firewalls. Okay, so the firewall characteristics, all traffic from inside to outside must pass through the firewall, but then only authorized traffic as defined by the local security policy will be allowed to pass. Okay? Techniques used by firewalls to control access and enforce the site security policies include service control, which basically means looking at the service, like the port numbers, the direction control, is it going in or out, right? So if it's coming from the outside in, it's not allowed. Also, you can authenticate users, and you can have more sophisticated ways of looking at the behavior. Are we getting too many packets within, half a second, right? If that's happening, why are we getting so many packets? The rate has gone up. It could be a denial of service attack, for instance. Okay, so that's in essence what a firewall is nothing more than a C program, and it's a packet sniffer, so it can grab all the packets efficiently, really fast, and decide if it's going to allow them in or not. Are there any questions so far? All right, no questions. So the packet filtering firewall is the simplest one, and that's really the one that you're looking at or exploring with UFW today. So applies rules to each incoming, it applies rules to each incoming and outgoing IP packet. It's gonna be, every packet is basically considered to be independent, right? When the rule is applied. So it's not like you look at the previous packet and then given that packet, I'm gonna look at this packet, and with that information, I'm gonna make a decision. Usually it's just each packet. And so typically what you have is you have a list of rules based on matches in the headers of the IP header, the TCP header, or UDP header, ICMP headers, etc. Remember that a packet has, like an Ethernet header, right? And it'll have like an IP header. Then after that, it could have a TCP header, payload. But you could also have a UDP packet. You could also have an ICMP. And so on. All right, so this is something I think you've been looking at in your Wireshark tutorial. So you probably saw some of this information there. You can definitely see it in Wireshark, but you should always understand that that's really what a packet looks like, and that's how you're analyzing. Okay. All right. Excuse me. So you typically have a list of rules, right? And then the packet decides to forward or discard the packet based on rule matches. So that's, we saw an example in the lab document where we saw the drop or accept, right? So drop into the line or accept. Okay, and so you have that piece of information. The filtering rules. So the filtering rules are based on information contained in the network packet. So usually what it does is it's gonna look just at that header, or it's gonna look at that header. It doesn't usually look at this one, right? Because that's more of an application layer. Also, usually this is encrypted, right? And so, you'll have issues with that. If something is encrypted, you can't really look at it, right? And the firewall will not be able to look at it. And so, but it usually focuses on things like IP address, destination, source and destination, transport level protocols, IP protocols, and so on, the interface, etc. Okay, so that's what is called a packet filtering firewall, and that's really, you know, all we're going to look at right now when you look at things on a per packet basis, such as the UNIX UFW firewall that we're studying in our lab this week. So the advantages of this, you know, as you're downloading a movie into your, you know, your house, etc., you don't want to see that lag, right? Or if we have this communication, you don't want to see this like lagging, like issues that we have with audio last week. So you want the process to be really fast. Okay, you want it to be really fast, and therefore you need something that is simple. So the advantages are simplicity, typically transparent, very fast. It's done at a very low level, at the kernel level, right? So of a Unix or the firmware of any kind of router or firewall that you have in your organization. There are some weaknesses to this approach, though, right? You know, firewalls are only specific to the rules, so it cannot prevent attacks that employ application-specific vulnerabilities, right? Because you can't really tell what's in the payload. They may also have some logging issues and so on, right? So there's some weaknesses. They're very, it's in the sense that they're both very simple. That's actually both an advantage and a disadvantage or a weakness. Now, there's also some other types of firewalls called the stateful inspection firewall, and usually the previous one is stateless. You don't keep track of anything, right? You don't keep track of anything. So that's stateless. In the stateful one, you have some information that you're keeping. So it tightens rules for TCP traffic by creating a directory of outbound TCP connections. Okay? So there's an entry for each currently established connection, and then the packet filter allows incoming traffic to high-numbered ports only for those packets that fit the profile of one of the entries in the directory, right? So that's really the idea, that you're keeping some kind of track of what's going on. Okay? And then you can see an example there of the process. And you can see the table there as well, so it just keeps track of your connections in the firewall itself, so it knows when something initiated from the inside, and now you're just looking at it. All right, host-based firewalls, these are used to secure individual hosts. So the difference would be that the network firewalls are like the router that you have at home, whereas the individual host firewall is the firewall excuse me, is the firewall that you have on your home computer, right? So all of you right now are using some type of a computer to watch these videos, probably on Windows or Mac, and all of those have built-in firewalls, right? And so that's a host firewall. The UFW firewall is, you know, in Unix falls within this category. Can be a package, or it's usually provided. So usually Windows and Mac, they come with their own firewalls, but you can also add on another program, okay? And so, you know, the difference is that with a host firewall, you can have rules that are tailored for the host environment, right? So now it's, you know, it's only specific things. Maybe the network firewall allows SSH through the network, but your firewall, the host firewall, does not. And so you can have more, you know, more rules based on what your needs are. Okay. And this is just an example of a configuration here where you can have multiple firewalls. Notice here there's, you know, this is the internet, so it's untrusted. You have network traffic coming in. And then over here you have what is called the DMZ, and then you have the internal protected network. So as somebody comes to through the internet to the first router, it might hit this firewall, and this firewall has is basically less restrictive. So this is where people might want to access, for instance, your web servers from the outside, right? So you want to allow that. So probably on here, port 80 is open. All right. But then as you start moving further into the network, this is the actual office where you have your accounting and finance and where all your workers are. And so you don't want to have people accessing through that. And so here, for instance, a lot of the many ports, most ports are closed. This is also usually where you have like a VPN server. So here you'll have a VPN server, and that means that port will probably be open for VPN connections and so on. So it just becomes a little bit more restrictive as you go in, and that's really the, you know, the main idea with this. Okay. All right, then as you talk about firewalls, you have these two concepts of ingress and egress filter, right? So, and that's because that has to do with the direction, right? So if you remember, you have the internal network, and then you have the external network. So this is your firewall. This is the external network. So that's the web or the internet, right? So you're coming in from an less trusted to a more trusted. So you have these terms of ingress and egress. So ingress just means traffic coming into your network, right? And then you have egress, which is traffic leaving your network. So originally from the inside out. So I've said this a couple of times already. You basically want to have a specific type of configuration if you have a firewall. For incoming traffic, for the incoming traffic, you want to block all traffic in from, you know, the web, right? And then leaving traffic. So, but also this is more generic actually. This is just saying block all in from IP. That just represents that whenever you write rules, you're actually specifying direction. And then notice over here for traffic leaving, you could do something like block all out from IP. All right, and so those are ways to specifically start to write rules. Now, I should say that when you write rules, you're going to write them in more of the UFW syntax. Let me do this. So you have syntax, right? And then you have logic. So this relates to the rules. So when you do like UFW, and then you do IP tables, these are all Unix specific. And then you have like Cisco, and I ran out of room, but other ones as well, ... The syntax will be different for all of these. It's different, okay? But the logic is very similar, all right? So the logic for all of these is very similar. So anything that you're learning here about, you know, like the chain rules and everything in Unix, you know, once you start thinking about that in terms of Cisco, it'll be the exact same principles, except that the syntax of it will change. Okay, you know, obviously every firmware and other machines will have this. Also keep in mind that nowadays you can do this all through like GUI configuration. So you don't always just have to type in the command line. You can also go into the GUI and you know, point and click and so on. And really, one of the reasons why Cisco has a lot of competition nowadays is because there's a lot of these devices that just have made this so simple. All right, and so, you know, but anyway, at the end of the day, the rules are still in some text file somewhere, and they're still pretty much very consistent. It's just you know, as they evolve, they all have their own ways of writing the syntax. Okay. Okay. So this is just another example. This is a lab I usually do in 454. All right, and you know, we have our physical lab. And so this is another example. I like to kind of stress this. You have an internal network, right? So that's going to be the 10.0.1 network. So that's another thing that you do in security is that you want to have these networks. You have the DMC, which is a 192.168.1 network. And then over here, this would be like the internet. Oops. All right, so by being able to have that separation of subnets, you can add rules here and rules here that are specific to those subnets, but also, you know, you can allow port numbers. You know, you block by port numbers, or you allow certain services, etc. All right, so this is just an example of the use of a firewall. So you can see the firewall is being used here. All right, you can see it's got two network interfaces. You know, usually one is called the outside, one is called the inside, right? And then this would represent your company's business. So this is the internal network. And then this is just a router, but a router with ACLs. And a router with ACLs represents, also a type of a firewall, because, you know, at the end of the day, it's all about restricting rules or not. And then the individual machines can also have their own firewall. So for instance, if this is a Linux Apache web service, then here you can have UFW, for instance, enabled, and that's restricted. So it's all about, firewalls are about that, whether network or host based. They're about adding rules that allow traffic through or prevent traffic, etc. Okay, and then, so are there any questions before I continue? All right.
Not right now.
Oh, not right now. Okay. All right. So yeah. So that's, you know, that's kind of our discussion of security. Let me see how many slides I have left. So this has a lot of slides. All right. Let me just look at these slides. So from this point on, you know, this just kind of goes into how to set up this network. So I'm not going to get into all the details of that. So let's see. These are just some examples in Cisco of how to do this. You can, you know, we'll do something like this in 454, so don't worry about it here. Okay, here I do want to talk about this. All right, so as a system administrator, right, you're going to think of ACLs and filters and rules. So there's one concept that, you know, I should mention, like one definition, and that I think I've mentioned it several times, but I should provide a formal definition so that you're aware of it. So in network security, there is something called domains of trust. Okay? Domains of trust. A very simple concept. It just means that how do you segment, and it's more of a, it's not so much, let's say, a physical thing, but it's more of a logical thing. How do you segment your computers, your equipment, your network devices based on the level of trust that you have for that segment? All right, so, you know, what that means is, you know, if you notice over here, here we have the internet, right? And then you have an external server, such as a web server. Right, and then we have the WAN connection here. And then after that, we have like an internal server, user PC. So this might be like the marketing department. And then over here, you have another segment, the finance department, you know, the payroll server, and so on. All right, so the idea is that you segment out your computers, right? You're segmenting out your computers. So which one of these 5 areas, which are called trust domains, would you say is the least secure, or not least secure, but the most trusted, let's say? Which one is the most trusted? Which one? Or which one is the least trusted? How about that?
Would just the internet be the least trusted?
Yes, the internet, right? Because the internet, you have no control over it. You know, hackers are there, right? So hackers are there. So you can see the line here, right? The line is pointing in that direction. As you start going from the internet all the way to the internal network, you know, the trust level goes up. So here you can see it's darker, so no trust. High trust, you know, it starts to become lighter. And so you start to see this approach, okay? And this is, you know, this is an important concept because as you do network segmentation, you really end up, you know, with, you know, thinking of, okay, what is it that I'm concerned about? As you know, for instance, a web server is less trusted because it needs to be accessed from the outside, from the internet. And if something needs to be accessed from the internet, it means that more ports are open for people to log in to that. All right, and so that's the idea. So domain of trust is an important concept in network security. And as a system administrator, you would have to think of that. So given that we have a domain of trust, right, now we want to see how it would segment out. So if I go to the net, you know, here this just provides some various domains of varying levels of domains of trust, from e-commerce to the internet, public servers to department-specific network and everything in between, right? But if we look at the previous one, I believe the next slide, yeah, it now takes that one, right? This one, domain of trust here, it takes this domain of trust, and now it's going to basically, oops, now it's going to take this one and start to create more of the physical network. So if you think about it, we had the internet domain over here. We have then some kind of least trusted over here, you know, for all your workers, the LAN, and then you have the data center. So if you think about it, you have your finance over here. You have your payroll over here, right? And so, and then you have maybe like, you know, worker computers, just you know, regular workers. And then maybe here it's not indicated, but here you have the web servers. So as you can see, what we're doing is we're putting in appliances that allow you to be more restrictive. The key thing to understand is here you have a router, here you have a firewall, here you have another router. All right, so this is really like the border router. This is what's saying, well, you know, I'm going to block things in the organization. This is a router, pretty much lets anything in. That's important because from the internet, you probably need to access the web server. But now you're going to hit this. Now, if you get, now, even if you're inside the network, whether you come in through VPN or you're just logged into these computers, you still have an additional restrictive device there with more ACLs, and that really then will block traffic, right, to the finance and payroll because those are segmented, you know, in a high trust area. Right? So these are high trust areas, and certainly you want to restrict them. So that's really the way it works. So from the initial scenario, of just thinking of the domains of trust like that, right, we can then go into start segmenting things, right? And that, again, ends up being this. If you notice, that is really this because this here's the router, and that's the firewall, and then here's just the internal network. Internal network, and so you can see that it kind of becomes that, where you have the router here, the firewall here, and this is the internal network. So your internal network is 10.0.1.0. Okay. All right, so that was domains of trust. Are there any questions about domains of trust?
No.
Right, no questions. Great, that sounds good. Just some important concepts. The last part is I'm just going to talk about a little bit more on the firewalls. So you have different types of firewalls. I guess you have a basic filtering router. This is pretty much the configuration you have at home. Okay, so usually at home you have your company, your ISP provider's router for your own, and then this is your house, and then that's the internet. So people should be able to reach as far as that IP address, but then they can't get access inside. Okay, so that's the easiest approach, right? So your routers all have some kind of a firewall. If you want to get access to the network from the outside, you will need to open ports. And that's, well, that whenever you do that, as you've learned, that creates some vulnerabilities. Then there's other setups are the classic dual router, the so-called DMZ, which I guess I should define that DMZ stands for demilitarized zone. And that's really the idea that from the internet, someone wants to access your web servers, classic example, right? But they should not be able to get into your internal network. So here you have more detailed ACLs. Here you have basic ACLs. So here, port 80 is closed, whereas here, port 80 is open. That's really what it comes down to in that idea. Things can get more complicated, right? This just means that you have a dedicated firewall here with more capabilities. Okay. It's just got stronger filtering, and it could impact performance. Obviously, as you're restricting, you're doing more things, so you need to have good hardware there. Right, so these are dedicated devices that are usually pretty good for this. The 3 interface firewall design, that's in case you don't want to have your configuration like this, where this is a switch where everything's connected. There are some firewalls, in fact, that have it's like they have a network card there and a network card there, but then they also have a set of ports there. And so you can connect the web servers to the firewall itself instead of having it through there. And that just means it'll have more security. The difference is you have different segments. So this will be segment 1, segment 2, segment 3. 2, 3. And so, by having different subnets there, it makes it easier to restrict traffic because you designate that the public servers are in a specific private network that's exclusive to them. And so now you write rules, whenever you write rules for that subnet, it just becomes clear what's allowed through and what isn't. All right. And then you can go even further with a multi-firewall design. And this will be something like when you have e-commerce and banking, you just want to have even more restrictive devices, right? And so here you can see there's 2 firewalls, there's a router, and really the idea again is that you're just adding more restrictions. As you go from untrusted to trusted, you have things where, for instance, people can't directly access, let's say these are the databases. So this is the database. The SQL, maybe I should say the MySQL database. right? So that's the MySQL database. And so if you're coming from the internet, you can get to that web server there. So you can, you can get there, but you can't go to the database. You will not be allowed. However, given some rules that you've given, this server can query the database. And so that's really what that does. So you start to have more restrictions, more rules, basically more closed ports. That's really what it means at the end of the day, more rules, etc. All right, so these are just some examples of different kinds of firewalls out there. Another kind of firewall is what is called a content firewall. This is the, if you remember in the beginning, I said that a packet looks like this. And then you have the payload, right? And we are not, when we're using, basic firewalls, we're just covering that. These types of firewalls, like the content filtering firewalls, look at the payload, which means that the data needs to get to the application, needs to get decrypted or whatever, and then you need to look at what's in the payload, look at the content of it, right? So it's at the application layer. So there's a proxy in Unix called Squid, right? It's a proxy type of a firewall, but really the idea is they allow you to look at things like this, okay? Obviously, that type of a firewall can be a little bit more restricted, can basically affect performance because now it has additional steps of looking at the payload and everything like that. All right? And you can see a proxy server. The way it works is, let's say you have a worker here, right? And, the worker wants to access the internet, so the worker would go like that. But with a proxy firewall, before the worker goes to the internet, it has to go there, and then it might be allowed to go in. So a little bit of routing has to be done so that certain types of packets need to first end up here before they're sent back out into the network. Right, so that's another type of firewall. We will see all these concepts in 454. So don't worry, this is just kind of an overview right now. We'll specifically get into these labs in 454. All right, so let's see. Okay, and I think that's basically it. Again, this just starts getting into like specific rules, access control lists, so you can take a look at some of the ideas here. Talks a little bit about devices and their syntax. Okay, all right, so I think you can read the rest of the material. This just talks about VPN, and you guys know what VPNs are. So VPNs are software that you can use to build private networks. So I'll leave you guys to read through. All right, so are there any questions at this time? If not, this is the lecture for today. Again, remember I went over security in general, and then I also assigned this lab. Okay, I assigned this lab. Okay, so make sure you go through it. Remember, on Wednesday we will have a lab session. So if you have questions, bring it up. I'll check to see if I have anything else that I need to cover as far as material, but otherwise just work on your lab, have questions or your project. And then that's it. We are done with content for the semester. And then just remember that I remind you again, next Monday we will have, so let me look at the dates here. So I'll remind you, this is very important. On Monday, April 27th at 2 o'clock through this medium of Zoom, we're going to have our presentations. We're going to see how that goes. I know we've never done that before, but I think you guys can share your screens and talk, right? So you will do your presentations. And we will also have Wednesday the 29th. So you have both days to present both projects, okay? And then so that's the plan for in a week, the 27th, you guys will do your presentations through this. And then finally, we will have our final exam on May 4th from 2:45 to 4:45. And remember that all your materials, lab reports, project reports, need to be submitted before the start of that exam. Okay? So that concludes our session today. If you have any questions, stay online. Stay for a few minutes just to see if anyone has questions. Otherwise, I'll see you guys on Wednesday. Thank you.